What's up? It's your boy Swervo here with another video. In today's video, we're going to be doing day 2 of lesson 0, which is really on exponent rules. All right, so we're going to try our best not to use a calculator here. It says numbers 1 through 6 simplify, rewrite in fraction form. Okay, so let's start with some negative exponents here. 2 to the negative first power. Remember, if you want to deal with a negative exponent and rewrite it as positive, you have to put it in the numerator or denominator. Wherever it is, you put it in the other thing. So think of this as in the numerator, it's like over 1. So then 2 to the negative first power will be 1 over 2 to the first power, which is just 1 over 2, 1/2. So here this is my negative exponent. So I'm going to be basically 3 times 1/4, which is the same as 3/4. So we'll write that as 3/4. Here, this is equal to 1 over 4 squared, 4 to the second. Again, I am rewriting that as a positive exponent by putting it in the denominator, changing the exponent from negative to positive. 4 squared is 16. Do the same thing. I rewrite this as a positive exponent by putting it in the denominator and making it positive. Last one, it's going to be 5 times 1 over x squared. 5 times 1 is 5, so I will put that as basically 5 over x squared. Make that look a little bit better. And now we will move on to, well, let's summarize here. So any base, we'll call it a to the negative n is equal to 1 over a. So that is how we deal with negative exponents. If it's in, um, it's just a number. Oh, let me add to that actually. So if it's a number, you raise it to the negative exponent, you put it in the denominator, and you make it positive. If it's in the denominator already, like let's say 1 over b to the negative m, well, then I will put it in the numerator. So that is the same as b to the n. Okay, so um, those are the two ways I think of negative exponents. All right, so now let's talk about raising something to the 0th power. Anything other than 0 raised to the 0th power is 1. So 2 to the 0th power is 1. Here, I'm going to deal with the exponent first. So this is 3 times 4 to the 0th is 1. 3 times 1 is 3. X to the 0 is 1. This is 5 times x to the 0th is 1. 5 times 1 is 5. The order of operations applies here, so that's why I am evaluating the exponent first and then doing the multiplication. So let's put some of these properties together here. So a little practice. Um, Notice I have a bunch of just numbers or variables with negative exponents. So I will put a 1 in the numerator, and I'm basically going to rewrite everything with a positive exponent in the denominator. Um, 2 to the 5th is what? 2, 8, 2, 4, 8 is 32. Okay, so here we go. I have again a bunch of things just being raised to negative powers. So it'll be 1 over all this stuff, but positive exponents now, since I'm putting them in the denominator. Since it's just a positive one here, I don't have to write that. Here we go. So we see a couple of terms with positive exponents. So I will evaluate those and I'll leave them in the numerator. 3 to the third is 27, y squared, and then x to the fourth is going to go in the denominator because it was negative. So now I put it in the denominator and made the exponent positive. Here I have sort of some things now in the denominator already with negative exponents. So that'll come up to the numerator. So this is just going to be 3 squared, which is 9. Um, so if I have variables with positive exponents that are in the numerator, I can kind of leave those there. So this will be z to the third. And then this term, since it has that negative power, I will rewrite in the numerator, making the power positive, and we are done. So z to the third, x squared, y to the fourth. If it had a positive exponent, I kind of leave it where it is. Here, so this is going to be just 1, so I can almost just, and it's not there, because 1 times that is that. So basically, the 5 will be in the top. That's going to go on the top, make it positive, and then this will go in the denominator and make it positive. So they kind of got flipped, and the exponents became positive. All right, moving right along. Numbers 7 through 10. So it says to rewrite with positive exponents. So just simplifying some stuff, it looks like I have 2 to the fifth and then 4 squared. Here would be x to the seventh, y to the fifth. Remember, when I am multiplying common base with, well, if I'm multiplying a common base by another common base with exponents, I add them. So that's how x to the third, x to the fourth, I add those exponents and I got the 7 there. Y to the second, y to the third, I add the exponents and I get the 5. Okay. Um, all right, so let's move on here. And this rule will apply even with negative exponents. So if you see here, I basically have 4 plus negative 3 plus 1. So that's going to be turn out to be 4 plus 1 is 5. 5 minus 3 is 2. So that'll be x to the second power. Okay, let's see here. Let's multiply the numbers first. 2 times 3 is 6. And then I'm doing an x to the third times an x to the fourth. That'll give me x to the seventh. And then y squared, y to the sixth will give me y to the eighth. Same base, add the exponents. Here we go. Another kind of way of writing it. Now they use parentheses. Still multiply the coefficients. Negative 4 and positive 3, negative 12. And then x to the seventh. And so this would be y to the 0 if you add 3 and negative 3. And that will be just 1, so I don't need it. Multiplying by 1 doesn't do anything since it is the multiplicative identity, which is just a fancy way of saying if you multiply by 1, you don't do anything. 10 times 3 is 30. Then x to the ninth and y to the sixth. All right, we are now on the second page. I encourage you to pause the video, try some of these on your own. Now we are looking at the product or the power to a power rule, sort of. So if you think about it like this, this would be taking x to the 10th, multiplying by itself 3 times, and then I can use the rule that I already know, the product of powers rule, where I just add the exponents. So this would be 10 plus 10 plus 10, which is 30. So x to the 30. Um, Again, another way of seeing this, multiplying all these things. So 2 times 2 times 2 times 2. It's going to be 16. And then multiplying a bunch of x's to powers, same base. So I add all those powers up. So it's going to be, um, what? X to the 20th. And the rule here is that if I have something like x to the m raised to some other power n, I multiply the powers now because I'm raising a power to a power. That is when I will multiply. So m times n. Um, and then the other rule that's kind of being shown here is um, the product to a power rule. So let's suppose I have two things and I'm multiplying them. Um, Basically, that exponent is going to apply to both factors. So it'll be a to the n times b to the n. So those are kind of some important exponent rules that we want to make sure we know. All right, so let's get some practice with it. Um, all right, so powers to a power. So powers to a power, I'm going to multiply. So I'm using this rule here highlighted in yellow. So that'll be 8x. Whoa, what am I saying? X to the 40th. Wait. So this is x to the 0. You can always simplify within the parentheses first. So this is really just 2y to the third because I'm multiplying by 1 in here, which I don't need that. So just I'm trying to trick you guys. I'm sorry. So now I'm using this rule highlighted in purple. So that'll be a product 2 times y to the third and then raised to the third. So then I'm going to use the rule in yellow for evaluating y to the third to the third. So that'll be y to the ninth. And then 2 to the third is 2 times 2 is 4, times 2 again is 8. So that would be my answer. Whoops. All right, one more here. So negative 3 squared turns into positive 9x squared and then y to the 10. So I'm using a combination of the two rules that I talked about above. Um, all right, moving right along here. So now we're going to see when we are dividing two exponents with the same base, you can see how many factors of 2 are going to cancel here. So I would get 2 squared. And the rule is if I have the same base, so suppose I have x to the m divided by x to the n, that is equal to x to the m minus n. I'm going to um, subtract those exponents. So let me highlight that rule. I encourage you, if you have flashcards or a notebook even, to write these rules down. One thing I always use to memorize things is write it down a bunch of times, say it back to myself, cover it over, write it down, say it back, cover it over. All those strategies help me remember things. So let's see here. I'm basically going to have three factors of x get canceled with three factors in the denominator here. So I'll have x to the fourth in the bottom and then nothing. Those are all going to get canceled. And then I'll have one factor of y cancel with one of those factors, one of the two. So I'm going to have y um, over x to the fourth. All right, so let's do these last few problems. 22 over 4, I guess I can simplify to 11 over 2. And then I'll have two factors of x cancel. That'll become a 2. And I'm going to stick that in the denominator and make it a positive exponent. So y to the fifth, and then that x squared is still up there. And this is 11 over 2 if I divide each one of those by 2. So that's going to be my answer. Um, Here, let's see what's happening. So, well, this is 1, so I can ignore that. And then it's going to be 16 over 9, and then x to the third is still going to be the bottom. Y to the fourth would be on top, and y to the first would be on the bottom, but then one factor of y will cancel with one of those four, making it a 3. And that is going to be my answer. Let's move that a little bit here, and then put an equal sign. Okay, putting it all together. Oh God. So these problems can get a little dicey, but you just have to go through them slowly, and they're, I don't know. I almost said fun. They're not really fun, let's be honest. Let's deal with this part first. So it's going to be x to the 10th. I'm using a combination of these two rules up here. So it's I'm applying this square to both this factor and y. So that's how I did the x to the 10th, and then y squared, and then, okay. 4 to the third is going to be 4 times 4 is 16, times 4 again is 64, and then x to the third, and then y to the negative 12th, because I am again using a combination of those two rules I just mentioned. Now, we still have some work to do. Let me move this over a little bit. Um, and let's see what's going to happen. So let's combine these x terms. So that'll be x to the 13th. Let's put the 64 in front. I'm just going to squeeze that 64 right in here. 64, there you go. And then okay, it's going to be y squared over y to the, well, because I'm putting that in the denominator and um making it positive. And then I'm going to have these sort of cancel out. So two factors of y. So two factors of y in the denominator got canceled. So now I only have 10 because I had 12 before. And that's my answer. Oh God, this next one, right? Well, you know what? It's not that bad. Hold on. This, what is that? Pause the video or think about it. Did you say it's equal to 1? You're right. So this whole thing is just going to we don't need it because we're multiplying by 1. Awesome. Then, okay, let's see here. So I'm just going to go for it. Just got to go for it sometimes. Negative 2, that power is going to be applied to every product here. So 3 to the negative 2, just going to write that. And then x, be careful here, I'm multiplying. Negative 4 and negative 2 is positive 8. Y to the negative 6. Okay, keep going. 2 to the third, and then x to the 6th, y to the negative third. I am applying that exponent to each one of those products using all these rules. I know. Let's see. Let's try to, and then all that stuff is gone. So, okay, let's put all the negative things in the bottom right now. So we have this that's negative, this that's negative, and this. So those will all go in the denominator and become positive. So 3 to the positive 2 power is 9. And then that'll be y to the 6th times y to the third. Well, that's just going to be y to the ninth. And then in the top, I'll have 2 to the third is 8, and then x to the 6th times x to the 8th is x to the 14th. And I'm done. Okay. You know what? Why don't you try these on your own? And you can see me in class if you have questions with them, or just keep trying until you get them. Use all the rules stated before. And I'm going to pause the video there.